Hey, Directrix here, another great math video here for you on graphing a parabola. So we've been graphing parabolas now for most of our mathematical lives. And this time what we're going to do is we're going to take that parabola and we're going to add a couple things to it. We have a focal point now, and we also have a directrix. And we're going to see how those each play out in their role in constructing a parabola. Most of the time we just think of y equals x squared as a generic parabola. And if a generic parabola is positive, then it goes up. And if the parabola is facing down, then it'll be a negative x squared. And so, but we don't really pay too much attention to what happens if y is squared. So here we go. We're going to look at some different generalities. So we have standard form. One is if x is squared, and that equals some 4py, then what we'll notice is that the form if p is greater than 0, we'll talk about what p stands for in a minute, but if p is positive, then we get a normal parabola that we've been drawing for a while, and if p is less than 0 or negative, then we get a down-facing parabola like this in the negative sense, and we've been seeing that now since for a while. Now let's take a look at what happens if we have y squared. So if we have the notation that y is being squared, well, that's equal to 4px. Okay, notice the y is being squared. So now what happens is we open up either one side or the other. And when that happens, then we get two y values, just like we do with the parabola. See, if I put in a negative x and a positive x, when I go up, I'll get two y values that are the same, right? So in this case, when we get y squared, then we should get two y values, and that's what we do. We get, it opens up positively to the positive x direction if p is positive or greater than 0, and if p is negative, then it'll open to the left. All right. So what we want to find out, though, is that there is a focal point and a directrix. Okay, so now we've got a couple new things that we're adding to the parabola. Focal point is where all the rays drawn in, and I'll draw a little picture of it in a moment, and the directrix are p distance from the vertex. Okay, so in general, if we look at a normal parabola, here we have, I'll just use this as an example. We'll look at some other examples in a minute. But if we have x squared equals 4py, then we get a general positive parabola. The focal point is p distance away from the vertex, okay? And the directrix, which is just either a horizontal line or a vertical line. And what that does is when we have rays that come into the parabola now, we will see rays that come in will bounce off the inside of the parabola, and it will go directly to the focal point, right? And we come here, we go directly to the focal point. Now, we'll often see this in satellite dishes. We might see this if we're if you have a magnifying glass, we'll see light rays come in and we'll focus them into a specific area. So those are just some applications of this. Now, what does this directrix do? Well, the directrix, on the other hand, is when there is a value that is going from the focal point to the outside, right? And that exact same distance is the distance from the edge to the directrix. So this value and that value are the same. And that would happen anywhere. If I were to draw another line that came straight out here to the edge of the parabola, that distance there is the same distance as if I were to draw a line, a perpendicular line to the directrix. Now, drawing not to scale, obviously, but you can kind of get the idea that this line right here is congruent with that line, and this line here would be congruent with that line. And so what that does is that helps us draw the parabola and make sure that the shape is congruent. All right, let's look at an example. How do we do this? So what do we do when we're drawing these things? Well, example number 1 says we've got an x squared and it equals 12y. So we need to find that p distance from the vertex to establish our focal point and our directrix. So what we're going to do is we're going to set 4p equal to 12. And if we divide by 4, we divide by 4. 12 divided by 4 is 3. So we get p distance away. So now what I want to do is I know that my focal point is at y equal 3 because my parabola is positive, right? It's pointing up. And my focal point's at 3. My directrix is a horizontal line at y equal negative 3. And now what I need to do is I need to establish some points on the graph to graph it. So I know one of the easiest ones is 0, 0, right? If I put 0 here and 0 there, then I'm going to get 0. But now I want to figure out, well, where would the next spot be? So 12, I go to my perfect squares. So what can I multiply by 12 in order to get a perfect square or divide? I chose 36. 12 times 3. So if, or if x is negative 3, that means it's 9. 9 divided by 12 is 3/4. So my y values will be 3/4. If I multiplied y by 3/4 and then I took the square root, I would also get the same thing, plus and minus 3, because 3/4 times 12 is going to be 3 times 3, which is 9. The square root of 9 is plus and minus 3. So then I can go ahead and graph my parabola there. All right, let's look at another example. In this case, we've got y squared equals negative 8x. So again, I set 4p equal to negative 8, divide by 4, and I get p is equal to negative 2. Now in this case, I have a y squared, so I'm either going to be opening in the negative direction or I'll be opening in the positive direction. And I look right here at the p value, and that p is negative 2. So I do know that I'm going to be opening in the negative direction of the x's. And the p distance will be negative 2. Or we could say, most likely we would say that the distance is the absolute value because we're going to go positive and negative. So we get p is equal to negative 2. That's going to be our focal point. And then we go back to units, and that's our directrix, okay? Now we just have to graph it. So we just put a simple x, y chart together. X and y, again, 0, 0. These all start at the origin, 0, 0. And then I think, well, where is, if I go negative 2, right, as my x, in that case that's 16. So now y, when it's squared, is plus and minus 4. And so I can graph at y 4 and x is negative 2. Then that gives me 16, and then y squared is 4 and 4. So it opens up and hits 4 and 4 that way. All right, so that's basically it for a parabola starting at the origin. And what we might want to do is just to clarify, that distance is the absolute value of p because we're going either up and down or side to side for that p value to get those directrix and your focal point. All right. Well, hope you've enjoyed that. Thanks again. Have a great night. We'll see you. Peace. Directrix out. See ya. That's math. Graphing parabolas. You bet.